Here, I will show a custom template that I did for one of my clients. Here, we have the concrete shaft, which is the vertical space designated for the lift to travel and the lift mechanism that operates inside it. The concrete shaft can expand or shrink based on the capacity requirements. This fully parametric model adjusts component sizes with a few numbers of inputs for different lift sizes. Let's check. This is 1600 capacity. We're gonna make it 2500. But before that, let's check this. So right now we got here the machine, which has 4 belts. The hitch point in front also got 4 belts. We got 3 yellow plates. The clearance between the red channels varies depending on the lift capacity. Let's have a look at the counterweight. We have this C channel, just look at it for later, and also for 3 belts everywhere. Okay, even the railings will change in size with the when we change the capacity of this lift. Okay, so here we're gonna change the width of the lift, make it 2500, and the lift capacity, let's make something like 2750, quite big machine. And everything adjusts to the new sizes. So now we got 6 belts, 1 more plate before we have 3, and there's not a slot in that last plate. We got a wider cabin, lift cabin, right? So over 30 parameters adjust instantly, demonstrating that interconnected adaptability of each component to suit the new lift capacity. Now we got 6 belts here as well. Different diameter for the sheaves, bigger weight billets. So every component, including the railing that assists the lift cabin up and down, was updated to fit the new requirements. So now let's reduce the lift capacity from 2750 to 1 ton. So quite smaller, right? Okay, so it's everything adjusts again. Now you see here how this is no longer a C channel, now it's a plate. The weights went a lot thinner, like less weights. Even the sheaves where it's less diameter, and they went from 3 to 2. This separation changed. Everything that you see here, even the railing, everything just automatically changed, right? You can manipulate everything. So for example, you got this bracket here, you make it, I don't know, 1. So you can either do things manually, like changes manually, or automatically, right? Here I'm doing a manual change. Or you can bypass any like this model is built in a way that you can bypass anything that is automatic. So that's for more custom-made models, right? So this model is not just the model, but the documentation is already made in a template. That's what we call a template. So basically, when you go here, for the plan views, everything is already there. If I change that here, all the drawings will update in real time as well, right? Dimensions and everything, they always there. So it's not like they have to make dimensions or create dimensions every time they do a new project. Also, all these numbers that are here, they update automatically. I just say check, just because you need to double check. It's all automatic, but it's good to always check. All these numbers update automatically as a report when changes happen. We have another one that is similar, but is with a structure, with a tower. That one can also be changed. You know, the tower can be adapted to whatever we want it to be. Right, so everything will adapt. Yeah, so we can have many, we can make it taller, we can make it shorter, we can bring this family up, down. So yeah, this is basically an example of what we can achieve with parameterization, reducing a lot of drafting times and achieving documentation pretty quick, making the families adapt to any type of projects, adjust to any type of project, and be easily adapt to that project just by changing parameters. To clarify, in case you were wondering about this clash, here, it is due to the shaft height, the overrun, not being adjusted yet. So I'm going to adjust it. Once we adjust that height, the clash will disappear. We can also raise the concrete height to provide more space for the hooks. Okay, so that concludes with today's session. Thank you for watching.